Welcome students, I am Nikita Jain. Today I am going to start the next chapter, that is gravitation. Gravitation, you know very well about the gravitation. You can click something, okay. What is the picture is showing off? The picture is showing off that once upon a time Newton was sitting under a tree and he saw that apple fall down from a tree from upward to downward direction only. Then he thinks, why apple falls only in downward direction? So he invented the theory of gravitation. So today we will start that what is gravitation. When a body is thrown up, it reaches a certain height and then fall down. When take a stone and thrown it up, when you thrown it up, then it will go at a certain height, then suddenly fall down, rise down. So the downward pull of the earth on the body decreases its velocity in the upward direction to 0. So velocity will be decreases from starting to 0, from the initial to 0 at some height. The body cannot rise further. This is therefore the maximum height. So when the stone reaches at a particular height, that means if the stone will reach at this height, so this height is known as maximum height, okay, and the velocity will be decreased suddenly and it fall down, okay. So the same downward pull of the earth on the body makes it fall downward from the maximum height, okay. So this is the basic concept of the gravitation. Based on these findings, Newton postulated this famous universal law of gravitation in 1687. It is very important law ever in physics, that is law of gravitation, which is postulated by the Newton in 1687. This law is also known as Newton's law of gravitation. Don't be confused, there is a two name. First is universal law of gravitation and another one is Newton's law of gravitation, okay. So he is the scientist, that is Newton, Sir Isaac Newton's the universal law of gravitation. He invented universal law of gravitation. He stated this law, okay. So firstly we will start from introduction of gravitation. An object changes its speed or direction of motion only when a force is applied on it. So we have already discussed the force and laws of motion in the previous chapter. We are very well known the term motion, we are very well known the term force. So what is force? When the object felt something, okay, only object can felt something and it will change its state from rest to motion. That means the object is in the force condition, okay. You can see a person is here, okay, person pushing the block, in which direction? Direction of motion of the box, okay. So what he is trying? He is trying to applying force, he is trying to pushing the block, okay. Now force and acceleration. What is force and acceleration? Application of the force accelerate the object. Here a tennis player hits a ball and see the ball is moving very fast and its direction of motion is also changing, okay. You can see, you can relate this example. So this is the reason that a tennis player, when the tennis player hit a ball and we see the ball is moving very fast and the direction also can be changed. We know the characteristics of the force that force and motion, that the speed and direction may also be changed if the force is applied on it. We can take another example to understand this. Where do we always fall? If you will jump, then why you fall down? This why the reason? The reason is, why is it that? Because of when we jump, we always land on the earth and do not remain suspended or move upward, okay. The reason behind what makes us to fall on the earth always. There is always some force acting on that guide our direction of falling. The second reason is that no matter from where ever we jump or we drop object from anywhere, they will always fall towards the earth, okay. And what makes the apple to always fall on the earth? It was Isaac Newton who posed this question and answered it also. Newton stated that all objects attracted each other along the line joining their centers. Okay, so this is the reason you can see in this picture. Okay, every object in the universe attracts every object other towards itself. So this is the main reason, this is the main line. So you have to learn that every object in the universe attracts every other object with each other. This force with which two objects attracted each other is called the force of gravitation. When we will talk about the gravitation now, then the force of gravitation is most important. And what is the force? It is the force by which two objects attracts each other. This is known as force of gravitation. The force of gravitation acts even if there is nothing connected to the two objects. We have already discussed about non-contact force or field force. If two objects are not in contact but still attract to each other, that means there is force of gravitation. Okay, so there is no compulsion that the body will be in the contact situation. It can be in non-contact or field force. Okay, example, just like you can see, there is a object M1, there is object M2. Okay, but both are attracted to each other because of the force of the gravitation. We can take an example of planet system R. Okay, so now we will discuss that what is the universal law of gravitation. Newton did not stop after proposing that a force of gravitation exists. He'll discuss about the force of gravitation. He will not stop only he did not stop only there. He expressed the law in a clear and precise language, the language of mathematics. According to mathematics, what we can say, any two particles with masses m1 and m2 attract each other by a force whose magnitude is directly proportional to the product of the two masses, that is m1 and m2, and inversely proportional to the square of the distance, that is capital R, between them. The direction of the force along the line joining the two passes. Okay, so what we can say, according to mathematics, according to the definition, what we can say that F will be directly proportional to m1 and m2. What is m1 and m2 over here? m1 and m2 are masses. Okay, so F will be directly proportional to m1 and m2, but it will be inversely proportional to the square of the distance. Okay, so this is the basic. When this is also force, this is also force. Okay, force also related to masses and force also related to the distance between them. So we can equate this equation. If we will equate this equation, what we can write? We can write that F1 will be directly proportional to m1 m2 divided by r square. Okay, and when we will remove this proportionality sign, then F will be equal to G m1 m2 upon r square, and this G is known as gravitational constant. Okay, so this G is known as gravitational constant. There are two masses m1 and m2. It is not compulsory that masses will be same, it can be different. Okay, and the distance is r. So what is the formula? F will be equal to the G m1 m2 upon r square. That means it will be directly proportional to the masses but inversely proportional to the square of the distance, and this is known as universal law of gravitation. Very important law, and the mathematics formula also. So where F in the expression, you know that expression. So where G is a gravitational constant, it does not depend on the value of masses or the distance between the masses. Okay, the constant G will remain the same for any two objects anywhere in the universe. m1 m2 can vary, r can vary, f can vary, but G is constant. Okay, G has a constant value for hold the object in the universe. So, what is G? G is the gravitational constant who has the fixed value. Okay. So, the value of G is 6.6734 multiplied by 10 raised to power minus 11 Newton per meter square per kilogram square. Okay. So, this is the value of capital G. Uses of gravitation. What is the uses of gravitation? It is the gravitational force that keep everything at its place. Otherwise, we would have been floating in the air. If the gravitational force is not occur, then what happens? We will flow only in the air every time. We can't stay, we can't even move on the earth also. It is due to gravitational that we are walking on the earth. We are not able to walk on the earth if there is a gravitation. The situation will be like that. We are like just moving in the air only. It also keep the earth, sun and other bodies at their places. Okay, it is responsible for many natural phenomena on the earth like tides and orbiting of moon around the earth. So, there are so many uses of the gravitation. Okay, you can see. Now, the next topic is, we can say there is another statement of universal law of gravitation. What we can say, that consider two bodies A and B having masses m1 and m2 and r. You can see here. So, this is m1, m2 and distance is r. Okay. So, this is like when the question is asking that write the universal law of gravitation. So, what you have to write, what the language you have to use. So, this is the language you have to use. Okay. This language you have to use. What you have to write? You know that what is universal law of gravitation, I have already discussed, but this is the slide that what the answer you have to written, because the question is asked in many times in NCERT and NTSE that write universal law of gravitation. So, what you have to write? Firstly, you have to write that according to this law, the force of attraction between two particle or object is directly proportional to the product of the masses and inversely proportional to the square of the distance. Now, what you have to do? You have to draw this diagram and you have to write that consider two objects A and B with masses m1 and m2 and the distance between two objects is r. Now, what you have to do? You have to write these equations, that f1 will be directly proportional to m1 m2 and f will be directly proportional to 1 upon r square. When we combining this equation, we will get this formula. Okay. So, you have to write accordingly. You can see in this diagram, okay, what you see, that there is a geostationary orbit. Okay. What you can see, there is a Fg. What is Fg? Gravitational force. And what is the gravitational force here? G m1 m2 upon r square. We can calculate the gravitational force on the earth by this formula, G m1 m2 upon r square. So, we can calculate the gravitational force for any object by using this formula. Now, the unit and value of gravitational constant, it is also important. Okay. So, according to Newton's law of gravitation, force between two bodies, there is m1 and m2 masses separated by the distance r. So, we can write, we know that formula. If we rearranging this formula, we can write like this, G m1 m2 will be equal to the f cross r square and we can find out the value. So, this is the formula to find out the gravitational constant. Now, the SI unit of G can be obtained by putting the unit distance. If we will put the unit of force, masses and r, that is the distance. So, what we will get? We will get that unit will be Newton per meter square per kilogram square. Okay. If m1 and m2 is 1 kg and r is also 1 meter, that what we can say? We can say that G will be equal to the F force, gravitational force will be equal to the gravitational constant. Okay. Here we can say that universal gravitational constant G is numerically equal to the gravitational force of attraction between two bodies, when the condition is that when m1 and m2 will be equal to the 1 kilogram and the distance r will be equal to the 1 meter. The value of G in SI unit will be 6.67 into 10 raised to power minus 11 Newton meter square per kilogram square, and in the CGS what we can write? 6.67 into 10 raised to power minus 8 dyne centimeter square per kilogram square. Okay. Now, the importance of the universal law of gravitation, it is also a very important topic. The question is asking that what is gravitation? First topic is that. After that, the question is what is universal law? Then what is the value of universal, what is the law of gravitational constant? What is the unit of the gravitational constant? And now the next topic is what is the importance. So, the gravitational force is one of the fundamental force in nature. The gravitational force is responsible for the following. Okay, first is that the existence of the solar system, motion of planet around the sun, motion of the planet around the sun is just because of gravitation. There is gravitational forces attracted to each other, holding the atmosphere near the surface of the earth. Okay, there is so many dust particle, there are so many pressure, there are so many gases and the atmosphere holding by the gravitational force only. The flow of water in the rivers just because of gravitation, for rainfall and snowfall, the reason is gravitational force. Motion of the moon around the earth, occurrence of tides, prediction about the solar and lunar ellipse made on the basis of this law always come out to be true. So, all these are the importance of universal law of gravitation. Okay. There is a difference between universal law of gravitation, importance and characteristics. If we will talk about the characteristics, then what is the characteristics of the gravitational force? Gravitational force between two bodies or object does not need any contact between them. First thing is that there is no need to be in contact. There can be a field force, the object can be in non-contact. It means gravitational force act at a distance also. The first characteristics, and the second characteristics is that gravitational force between two bodies varies inversely proportional to the square of the distance between them. Hence, gravitational force is an inverse square force also. Okay, don't be confused. There are three names. First is universal law of gravitation, Newton's law of gravitation, inverse square law. If the question is asking that what is inverse square law, then you have to write about like what is universal law of gravitation. And the third one characteristics is that the gravitational force between two bodies or object from an action and reaction pair, if object A attract object B with a force F1 and the object B attract A with a force F2, then we can say F1 will be equal to the F2. You can see there is a body A and there is a body B, mass M1 and M2 is here, the force is F2 is applying and the force F1 is applying. So, what we can say according to the universal law of gravitation, that the both forces will be equal, that means F1 will be equal to the F2. So, this is the basic characteristics of universal law of gravitation. So, what we have to discuss till now, firstly what is gravitation, the definition of gravitation, what is the importance of the gravitation, what is the characteristics, what is the universal law of gravitation, and there is three names of the universal law of gravitation. First is Newton's gravitational law, inverse square law and universal law of gravitation. Clear? Now, the next topic is that estimation of gravitational force between different object. Till now we are discussing about the same object. Okay, masses are different, but we will discuss about the same object. But what happened when we will discuss about different object? What the estimation, the formula applied for calculating gravitational force between light object and heavy object. One body is lighter in weight and another body is heavier in weight, then the formula will be same. What is the formula to calculate gravitational force? That is G m1 m2 upon r square. Let us take three different cases. Now, we are considering three cases to clarify estimation of gravitational force between different objects. First is that the gravitational force between a body of 1 kg and the earth. 1 kg and earth, oh my goodness, both are like one is light and one is too much heavier. We have to calculate the gravitational force between 1 kg of mass and second one is earth. You can see there is totally different objects. Now, second case we will discuss gravitational force between the sun and earth, and the third one is gravitational force between the moon and earth. So, we will discuss three cases to calculate gravitational force, and there are, you can see clearly, one object is lighter in weight and second object is higher heavier in weight. Okay. So first case is 1 kg of mass is putting on the earth surfaces. This is the earth, 1 kg of mass putting on the surfaces. So let a body of mass 1 kg be placed on the surface of the earth as shown in figure. The distance between the center of the earth and the body is equal to the radius of the earth, that will be equal to the 6.4 into 10 raised to power 6 meter. Now you know the radius. What is the formula? F equal to G m1 m2 upon r square. Now you have the value of r here. Okay. So the magnitude of gravitational force between the earth and the body is given by F equal to G m1 m2 upon r square, where m1 is 1 kg, m2 is 6 into 10 raised to power 24 kg. 1 kg is given because we are taking 1 kg of mass. So we know that one body is of 1 kg of mass and another is earth. So we know that the mass of earth is 6 into 10 raised to power 24 kg. You have to learn the value of mass of earth and you have to learn the value of distance between the earth. Okay. So the distance is r equal to 6.4 into 10 raised to power 6 meter. What is the value of G? This is the universal value. You know that fixed value is that 6.67 into 10 raised to power minus 11. Now what we have to do? We have to put all the value in the given formula. What is the formula? G m1 m2 upon r square. Put the value of G, m1, m2 and r. Now calculate. When we calculate it, then what we find, the value will be 9.8 Newton. Means what we can say that if we are taking two objects, one is lighter in weight, that is the 1 kg of mass, and another is heavier, that is the earth, then gravitational force will be equal to the 9.8 Newton. So this is the standard value, 9.8 Newton. Now the second case, now we are considering the second case, same as well. Okay, there is no difference. We know the formula is fixed. F equal to G m1 m2 upon r square. Okay, gravitational force between the sun and earth. Now we are considering two objects, first is sun and second is earth. So what we have to do? Firstly we have to calculate the masses. So we know that the mass of the earth is, mass of the earth 6 into 10 raised to power 24 kg. In the previous case we have already discussed the mass of earth. Now mass of the sun, that is m2, it will be equal to the 2 into 10 raised to power 30 kg. And what is the distance between the sun and earth? This is the standard value, 1.5 into 10 raised to power 11 meter. So all are the standard and fixed value. As you know now that what is the fixed value of G, capital G, 6.67 into 10 raised to power minus 11. Same as there is fixed value of mass of the earth, there is a fixed value of mass of the sun, there is a fixed value of the distance. Now what we have to do? We have to put the value in the given formula. When we will put the value of all these m1, m2, r and g, then the gravitational force will be 3.6 into 10 raised to power 22. The value you can see, 10 raised to power 22. Oh my goodness, this is the heavier forces. Means what we can say? We can say that, just wait, the gravitational force between the sun and earth is very large. Okay, so that's why this force keep the earth bound to the sun, because we know that sun and the earth is not in contact, but still they are attracted to each other. Why? Because the gravitational force between them is very large and it's up to 3.6 into 10 raised to power 22 Newton. So you can calculate the gravitational force. Now I am taking third case, that is the gravitational force between the moon and the earth. So firstly what we have to do? We have to find the value of m1, m2, r and g. We know there is earth now, so we know the mass of m1. Okay, so there is mass of m1 is 6 into 10 raised to power 24 kg. In the first case also we are taking earth, second case we are considering the earth. So you have to learn 6 into 10 raised to power 24. Now mass of the moon m2, that is 7.4 into 10 raised to power 22. Gravitational force between the earth and moon. What we have to do now? We have to put all the value m1, m2, g and r. G is the fixed value, that is gravitational constant. So the value is 2.05 into 10 raised to power 20 Newton. It's less than to the sun and earth, but still it is too large. Okay, so that's why moon and earth also be also attracted to each other without any contact. Okay, so now you get it. Now you can calculate gravitational force. There are three cases. First is we are considering 1 kg of mass and earth. In the second case we are considering sun and earth. In the third case we are considering moon and earth. And what we find, what is the conclusion? Conclusion is that they are not in contact but attracted to each other just because there is very large gravitational force between them. Okay, now clear? So this is the gravitational force. Now the next topic will be gravitational force and Newton's third law of motion. We have already discussed about Newton's law, Newton's first law, second law and third law. What is the Newton's first law? Newton's first law states that if a body is in rest, then it will remain in rest. If the body is in motion, then it will remain in motion until and unless the unbalanced force applied on it. Okay. What is the Newton's second law? We can say that F will be equal to the m into a, that is the product of mass and acceleration. And what is the Newton's third law? Action and reactions. Okay, if the action is there, that means there is always a reaction force applied over the body on the body. Okay, so now what is the link of gravitational force and Newton's third law? Okay, we will discuss this relation between gravitational force and Newton's third law in the next video. Keep watching. Thank you.